So, hello everybody, welcome to Geneva, to the EBU, and welcome to this SNCC seminar, which is a seminar which has been organized in a series of seminars we are holding to give information about DAB. We had a seminar on small-scale DAB in the past, we had a seminar on single-frequency networks, and this time we are going to have a seminar, as we told you, on signal distribution. Signal distribution is a very interesting topic. It's very important. It's about how to get the signal from the multiplexer to the transmitter. There are a lot of different ways to do this, and we are going to look into the different possibilities today. We have a very interesting list of speakers which have experiences from very different aspects of this sector. So we will talk about satellite distribution, we'll talk about IP distribution and on small-scale distribution. So the presentations will be very interesting and I hope you'll enjoy them. And so let's just start with everything. First of all, my name is Hans Wolter. I am the chairman of the SNCC, the Spectrum and Network Implementation Committee of World DAB. And I'm also, let's say, supporting the organization of the seminars. I work for a network operator in Italy, which is called DAB Italia. We operate a DAB network of nearly 200 transmitters at national level. Our customers are big commercial national radios in Italy. And well, if you travel to Italy, you will probably listen to our multiplex. We have a coverage of 93–94% of the population currently, and we plan to expand this in the future. So having said this, I'll put on my World DAB hat and give a short update on the activities of World DAB. Rebecca, you can start the presentation. Okay, so we start with, yeah, okay, DAB. So first of all, what is the SNCC, which I mentioned before? It's a committee which inside World DAB deals with spectrum issues and also with planning aspects, with network implementation, so with practical aspects. And so we look in multiplexing and signal distribution. It's a platform for an experience exchange, basically. We talk about we start really from the low level, how to build a transmitter side, to multiplexing, to signal distribution, etc. And as I said before, we also have the part of the spectrum. So we discuss about planning, interference. We're talking about the WRC-23. So we have a broad spectrum of activities. So what's the situation of DAB today? It is really firmly established in Europe. We have this wonderful central corridor where we have regular services. If you have been to DAB presentations in the past, you remember it started very slowly from the middle of Europe and now it's really expanding. We got France on the market. If you look at the launches, it's really progressing very well. Germany started 12 years ago and now everybody basically is pushing up. It's very good. We are very happy about this. And also around the world, the interest for DAB is growing, of course. We see, of course, regular services in Australia. We see tests and trials in some areas of Africa and South Africa and so on. So it's really progressing well. The last big developments have been, of course, France, which has been a very important launch because France was, let's say, one of the big players in Europe, which was missing. Germany is currently running out the second national multiplex. And there are launches of local or regional multiplexes ongoing, like here, the one you see in North Rhine-Westphalia, which is a state with a population of 18 million people. So I think more or less the population of Switzerland. It's pretty big. Yeah? And yeah, we have also had switch off of DAB. First example was Norway in 2017, and Switzerland now is preparing for a switch off in 2024, which is, everybody's looking at it. It's very interesting. And I think other countries are starting to consider switch off in the future because of, let's say, rising energy costs and economic reasons. How is DAB growing currently? You can see in the UK we have already 68% of digital listening. Most of this is on DAB. There's also an important part on online. In Italy, we have explosive growth of local services, of local multiplexes, because we see launches basically every month. And we have Belgium with a planned expansion of local services, and in the Netherlands, a third national multiplex has gone on air in late 2022. Also in Central Europe and in Eastern Europe, we have DAB progressing. Both Poland and Austria are extending their coverages. Croatia and Czech Republic are starting regular services. We have grouped this by color, as you can see. And what is driving the growth of DAB? So the first one, of course, why is DAB growing so strongly? One thing is, of course, the EECC and the regulation which forces all car radios to basically, or all the cars to have a DAB Plus radio installed in Europe. And this is really very important. This has changed very much the market. Of course, also DAB offers a lot of choice. On average, as you can see, we have 6 times as many stations as on FM. In some countries more, in some countries less, but it's an interesting average. You can see in the UK you have 56 programs comparing to 8 at national level. In Italy you have more than double the number, and in Norway actually they moved from 5 to 32, which is really impressive. Okay, let's go on. The other thing is, of course, the sound quality for DAB, especially in some areas where you have a lot of interference in FM. And I come from Italy, and we have really the problem that FM is so narrow, you always have some background noise. So the experience of FM is not that good. DAB is really significantly better. So, and DAB is a green solution. It's really very energy efficient. There are different studies. One is from the BBC, which says that DAB is 33% more efficient than DAB. We have also energy consumption calculations from just the broadcast side, which say that basically one DAB program consumes about 1/5 to 1/10 of what an FM program consumes, depending on the network, on the layout, etc. So there's a really big difference. Digital radios are becoming more and more energy efficient also. We have a couple of reports which demonstrate this. They've been done in the UK in 2020 and in Germany in 2021. And also, of course, DAB is basically traditional radio. So you have a receiver, you turn it on, you can turn it off. It's easy to use. It's free to air. You don't have gatekeepers. You don't have to pass through the internet to other distributors, etc. And it's really a very valuable tool in times of emergency. As we see also in Germany, there's an emergency warning project ongoing for disaster alerts, etc. This is very important, and you can do this with DAB very easily. As we said before, the costs for distribution of DAB, mainly because it's related to the energy consumption, but also to, let's say, the site occupation and to the rents, etc., are much lower than in FM. And of course, the pricing of the receivers has now really gone down significantly. So at the beginning, I remember the first DAB receivers were really expensive and complicated, and now you get the DAB receiver for 20 euros. So there's no issue anymore on buying a DAB receiver. We have a strong growth in the different European markets for the receiver sales, except I must say the UK, where the numbers are a little bit going down, but the UK has started much earlier, so they already sold a lot of radios. If you look at Italy, it's very much driven by the sales of car radios, of course, but we have a 94% of increase in DAB radio sales. France, 70%, Germany, 26%, Belgium, 39%, and so on. Really impressive, I would say. World DAB has also prepared a brand and logo guide, which World DAB members can download on the website. So to have a common branding for the DAB Plus logo and the products. And yeah, what are the commercial implications for DAB? For example, what people value choice. So in the UK, 22 million people listen to services which on traditional analog radio are not available. So the possibility to have more services on DAB, of course, offers the possibility also to the content producers to have more differentiated content. And in the UK, you see also that these audiences drive the commercial revenue. So you can really create new revenue streams with these additional and new programs. And that's very important. And you can, of course, this is still in a UK example, you can really work on the brand extensions because you're having the possibility to have more services on air, of course, gives you a possibility to get different brands or extensions of your brand on air. And of course, you can also extend the reach. So if you are a local radio from London, you might be interested in tapping into new markets and having the possibility and having space available on multiplexes in other local areas will give you this opportunity. So you can see this is an example from LBC, which had in 2014 an audience of 1.1 million in the London area. And it has now extended and has 3.3 million listeners combined, of course, on the whole network. But that's a very interesting extension and growth for radio station. Of course, you can also implement new business models because you have more options, more space, and non-traditional models with different programming. I think this is very much something for the UK. We have not seen that in other places, but it's an option, of course. And something which has been doing, for example, in Switzerland, very interesting is advertising over slideshow, which can be synchronized also to the advertising running in the background. So I think Stan will mention this during his presentation. Very interesting, I think. Okay, and of course, there's also other visual advertisings you can do on DAB, and this has also been done in Germany. Let's go on, yes. And let's go to DAB in cars quickly, which is probably one of the most important markets for us. World DAB did a car bias review. And what we found out basically is that people want radio in their car, and they might be less prone to buy a certain model, a certain car, if it wouldn't have a DAB radio. And radio listening in cars is very high. People listen a lot to radio in cars, although there are other options, of course, MP3, Apple CarPlay, and so on. However, people really tune in a lot to radio. In Italy, for example, always this example, I think 73% of the radio listening is done in cars. Switzerland is different. You have more listening, for example, at home, but this is very important. So radio in cars are very, very important. And people really would desire to be able to control, of course, the car radio via voice. So tune into the station and see some information on this. Okay. What is really important, and this is also a prominence question. First thing is, we believe really a radio button on the car radio is really essential. So people, the listeners, must find an easy way to tune into the radio, to select radio services directly. And of course, once you have this, you should have a station list. Generally, it's alphabetic because there is no other solution to this. And it should be really easy to program the presets for these radios because so people can tune in faster. Okay. The other thing is, of course, the automotive group is working on how to optimize the antenna performance of the cars. We are working on we have developed a set of test routes where car manufacturers can test the cars with under certain reception conditions in order to analyze correctly the antenna performance of the car. And also WordUp is investigating on how interference, for example, affects DAB radios in electric vehicles. Because, of course, you have high tensions, batteries, and all these problems which on petrol engines didn't exist. So there might be some issues, but for now it seems that there are no problems. Metadata, branding, etc. is, of course, people need an easy way to find the stations. So station logos are really, really essential. So if you operate a radio station, send the logos and keep the logos updated in order to allow your listeners to find you easy. We have the SPI service, which allows to send radios to logos to the car radios. On all newer models support this system now. And I think also broadcasters are starting to implement it massively. So this is very important because you will have your station list, but you also have a list of logos to tune into your radios. Radio in the car is changing. WorldUp is, of course, also embracing hybrid radio. So this is a combination of DAB+ and IP in order to, of course, extend the reach of the coverage. So this allows car radios in certain situations to fall back to IP if the car goes out of DAB reach, as long as there is, of course, a mobile coverage. To send additional data also via IP, so to integrate the information via IP, like logos and other information. And of course, also have localized information for the drivers based on advertising and consumer habits, etc. And WordUp is also working on Android Automotive. We also had some contacts, I think, with Google on this. And also, of course, we think that voice control for DAB radios or for car radios is very important. So assistants are already available in most of the new cars. And of course, you should be able to control your car radio with the voice, which not all car radios support nowadays, but we think it should be really a standard. So the priorities for World DAB, and then I come to an end on this. DAB is now standard. Basically in Europe, in all new cars, we have 100% of cars fitted with DAB in Italy, Norway. And I think the others are catching up really, really quickly. Switzerland, we have 99% and UK 98%. The worst one is Australia, but there is not the ECC valid, of course. So it's really very, very positive. Yes, the plan, of course, is we World DAB really wants to maintain this support, of course, for digital terrestrial radio. We think that free-to-air digital radio is very important for everybody, for the public, and because it allows a lot of choice. It is free-to-air. Free-to-air is really very important, and it is a very reliable system in emergency situations. Yes. Consumers with DAB receivers basically now new receivers have DAB. It's increasing significantly. In 2022, we have about 46% of radios and receivers sold at home with DAB. In some countries like Italy, for example, also normal radios sold on the shelves must have DAB. So, and we think this should be everywhere like this in Europe. We also want, of course, to have to make sure that the consumers, the car industry understands the importance for the importance for the consumers to have car radios with DAB in the cars, because radio is important in the cars. And therefore, we do this consumer research and try to show the car industry the importance of radio for the car market. We work with the car makers on innovation, especially on metadata and, as we said, voice control. And yeah, the way to success, this is the last slide, is the 5 C's. So it's really, we start from the coverage of the DAB services, we work on the content, we really look at consumer devices, which is very important because without these devices, you don't have the listeners. We look at cars and we take care of the communication. And yeah, that should be it. Thank you very much. Okay, so now, thank you for your attention for this first presentation from World DAB. And now we start with the real presentations with the seminar. The first one will be Tork Niendorf. Tork comes from Flensburg and he works for 2WCOM, a company most of you probably know. Tork has been taking care of the DAB project from 2WCOM for a long time now. He's very experienced and he has some interesting experiences to share with us, especially about ETI and EDI distribution over satellite. So the stage is yours, Tork.
Thank you, Hans. Thank you for the invitation to the SNCC. Just wait until the slide is shown here on the monitor. Yeah, I have it. Great. Today, I'd like to talk how DAB, and that is EDI or ETI, can be distributed over satellite. In the recent 14 years, we did a lot of projects and we have worked some good practices together with our customers and some effective schemes, how EDI and ETI can be distributed over standardized ways in a DVB-S or DVB-S2 transport system. I'd like to give first a little bit of introduction to me and our company. Then I'd like to explain EDI and ETI and give a short introduction. And then I'll come to some projects and tell about why there's a need for DAB distribution over satellite. Why did we do that? And one main topic is it's the encapsulation schemes. It's how is DAB transported over satellite? It's by the use of various encapsulation schemes and using common standards. I'll make a comparison, and at the end, I'll make a summary of these DAB encapsulation schemes. I'm working as a software developer at 2WCOM Systems. We are a manufacturer and we are situated in Flensburg, northern Germany. It's close to Denmark. And our company has more than 25 years of experience. We have software and hardware solutions for media transport over various distribution, contribution, and broadcast systems. And for the media, we are specialized in radio. That's DAB, FM, HD radio, and audio over IP. Oh, this photo is showing some of our team members at the IBC. I'd like now to introduce EDI and ETI. So what does EDI stand for? It's Ensemble Transport Interface. And that's the format typically coming out of a DAB multiplexer, and it's containing all the DAB radio services and all the metadata. And original, this ETI format is a 6,144 byte frame. It's transported over a G704 or G703 transportation network, a Telecom E1 line. In this picture, you can see that's the BNC, the coax cable there. This is where the ETI is transported. And if you want to transport ETI over IP, you need to encapsulate it, and that's where EDI comes into place. EDI stands for encapsulation of DAB interfaces. It's just the very same as ETI, but it's just converted to a format that can be sent over IP networks. Why is there a need for DAB distribution over satellite? About 10 years ago, we did a huge project in Norway. And as you know, Norway did the FM shutdown. So Norway has a lot of very remote areas, and Norway had to bring radio to these remote areas. And these remote areas, they do not have a good IP connection. And the people there, they want to listen to radio, to how to do that. And that's where the satellite, DAB over satellite, comes into place. Norway has a very, very lot of remote communications. So we distributed satellite systems with many low power gap fillers to distribute DAB to those remote areas. The second solution is that also the DAB feed over satellite can be used as a backup system to existing IP networks. In Norway, we did this huge project, and we installed together with Norgring Telenor more than 1,000 satellite receivers to get this DAB distribution operating in SFN mode. And the satellite receivers included ETI to ETI converters, and they used DVB-S2 generic streaming encapsulation, de-encapsulation mode. I'll come to that mode a little bit later. At the picture left, you can see Werner Drost, that's the founder of TWCom Systems, and Eike Schneider from our sales team. So I will just present a basic overview of EDI satellite distribution. At the very beginning, we have a DAB head end. That's where the DAB multiplexer sits. And the DAB multiplexer is generating EDI frames containing all the radio programs and metadata. Then this EDI frame is sent out to a satellite uplink station, and there is a satellite modulator generating a DVB-S or DVB-S2 carrier signal. And then at the transmitter side, this satellite signal is received by a satellite receiver. The EDI or ETI is decapsulated and sent out to a B transmitter, and the ETI DAB signal is distributed. I'll just give a small introduction to DVB-S2. DVB-S2 is a second generation standard for satellite broadcasting developed by the Digital Video Broadcasting Project as a successor of the DVB-S standard. This architecture is designed for broadband satellite applications such as digital television or radio, as well as interactive services such as internet access or content distribution. And the first generation of DVB-S has adopted an MPEG-2 data structure, which is optimized for the broadcast delivery of digital television data. And that's what we want to achieve. I think that's a good picture. We have our IP EDI packets coming in, and we just want to pipe them through a DVB-S2 system. And we want to have the same IP packets at the receiving sites coming out of the satellite receivers. And to do that, there are several encapsulation schemes available on the DVB-S2 system. And these encapsulation schemes, they enable the carriage of network layer packets over DVB networks. Depending on the schemes that are used, the transport efficiency or protocol overhead can be higher or lower. It's like a train transporting all kinds of data. I do not want to get much into this DVB-S2 framing structure, just to get an overview of the whole DVB-S2 baseband processing. I just want to leave out the steps behind the stream adaptation. I just want to show the very first steps, because these are the important ones for the encapsulation schemes. So in the DVB-S2 framing structure, we have continuous input data, and that's our IP EDI packets that are generated every 24 milliseconds. And these EDI packets, there are two available modes how these EDI packets can be transported. They can be transported over an MPEG-2 transport stream or through a generic stream. And this transport stream or generic stream is then carried over baseband frames. At the very bottom of a DVB-S2 system, it's always the baseband frames that are carrying the data. And as you see the picture of the train itself could be the baseband frame. So if you have a amount of baseband frames that are generated every second, and then you have the data that is just stuffed into the baseband frames. And for the first mode, generic streaming encapsulation that we have done in Norway, that's a very efficient mode to just transport IP packets over a DVB-S2 system. Generic streaming encapsulation is only available for the DVB-S2 mode. So IP packets, and that's our protocol data unit field, that's our IP EDI packet, for example. This EDI packet just packed into a GSE data field. Then we have a very little GSE header that builds up a GSE packet. And this GSE packet, as it is, it's directly stuffed into a baseband frame. So you have very minimal protocol overhead in a very efficient way to transport IP EDI packets over a DVB-S2 satellite system. In contrast, that's the second mode available, you have an MPEG-2 transport stream. And as you see, MPEG-2 transport stream, it's always consisting of TS packets. So TS packets are 188 byte long. They have a 4-byte header and a 184-byte payload field. And data is encapsulated into this payload field. And then these TS packets are carried over these baseband frames. They are copied into the baseband frames. And the first mode that a lot of our customers used when they do DVB-S2 transmission over satellite, it's the multi-protocol encapsulation. Multi-protocol encapsulation is a common standard mode to carry IP packets over MPEG-2 transport systems. And as you can see, it adds some overhead to existing overhead of a TS packet. So these orange fields are fields that are needed for the MPE transmission to fulfill the MPE standard, but they do not add any kind of information to the DAB system. They do not add any kind of information for the IP EDI packets. I want to show a second mode, which is not used very often. It's called unidirectional lightweight encapsulation. It's not used very often for DAB transmission so far. And the unidirectional lightweight encapsulation protocol is an alternative to NPE. which is a lightweight and extendable solution for carrying IPv4 and v6 and protocol data units over MPEG-2 transmission system. It can be also used to transport IP EDI packets over DVB-S2 system. It has been engineered by IP over DVB working group of the EATF and has standardized in RC 4326. We have a third mode or a fourth mode available, and just the mode we have started, which is also commonly used. And that's when you don't have IP EDI, because not all systems have this IP EDI format, and just transmission of EDI frames, which can be a little bit compressed to leave out all the stuffing data. And these EDI frames are just transported over a packetized elementary stream, just as normal video and audio distribution in a DVB-S or DVB-S2 system. I'd like to give an overview of the encapsulation schemes. So we have this first mode, which we have used in Norway. It's called generic streaming. And generic streaming is a very efficient way of transporting a lot of IP EDI packets. We have a second mode, which is deployed largely for IP EDI distribution, and that's multi-protocol encapsulation. It sits on top of an MPEG-2 transport stream, adds some protocol overhead to the IP EDI packets. Second mode could be unidirectional lightweight encapsulation, which has less protocol overhead, but is also sitting on an MPEG-2 transport stream. And then we have this mode where just the EDI frames are encapsulated in a DVB-S, DVB-S2 system sent out over MPEG-2 transport stream. And this mode is suitable when you have just transmitters who have EDI interfaces. So a lot of transmitters, DAB transmitters, they only have EDI interfaces and no IP EDI. So that's a good mode to use for. And these two modes, generic stream or MPEG-2 transport stream, are transported over these baseband frames. And in DVB-S2, that's also something that's commonly used. We have DVB-S2 multi-streaming, and you can combine these two modes. So multi-streaming technology includes a mechanism in the underlying baseband frame structure that merges multiple transport and generic data streams. In the baseband frame header, you have two fields available. And the first field, it's saying, okay, I'm transporting a transport stream over these baseband frames. And second mode is, it says, okay, now a generic stream is transported over these baseband frames. And the MA type 2 field, there is the ESI, it's called input stream identifier. And with the help of the input stream identifier, you can filter out baseband frames. So, for example, you can transport an MPEG-2 transport stream over ESI 0, and then the satellite receiver is just listening on ESI 0 and filtering all other protocols coming in on a different ESI. So you can combine MPEG-2 transport stream and generic stream. At the end, I would like to give a summary. And we have one mode, DVB-S, DVB-S2, MPE multi-protocol encapsulation. And this mode has a larger protocol overhead compared to GSE. It's highly supported. It's really easy to integrate into existing deployments in the satellite systems. We have successful deployments for our customers in Germany, France, Italy, and Australia. It's widely used. It's been highly successful to use multi-protocol encapsulation. And alternative can be unidirectional lightweight encapsulation. Second mode is DVB-S2 generic streaming, which has been used in Norway widely. And this mode is a very efficient mode because of the absence of a MPEG-2 transport stream overhead. And It has a high transport efficiency, and it could be combined as a multi-stream with a TS on a different input stream identifier. And the third mode available, it's the MPEG-2 transport stream. That's the mode where we have started just delivering ETI frames over a common DAVB streaming platform. And this could be compressed or uncompressed. At the end, I'd like to say a big thank you, because I've seen that a lot of participants and a lot of our customers are listening to this presentation. So I'd like to say a big thank you for the trust of all of you and for the projects that we have done in the last recent years. And yeah, and then I would like to go to the question rounds if there are any questions available.
No, thank you, Tork. The questions will be at the end in the session.
Okay, all right.
So first of all, thank you really very much. A very interesting presentation. And as I said, before sending you off to the coffee break, which will start now and will end at 10:40, please remember, if you're viewing online, send the questions through the chat, and we will then keep them later for you. And if you're here, write them down, and we have a Q&A session at the end of this seminar. So you might ask questions to Tork as much as you want.
Yes.
Of course, you can grab them also during the coffee break or at the lunch later. Thank you very much, Tork, and see you in half an hour.
Yeah, and I've just to add, we have also Arne Borsum available here, who is also working at 2W System, former at EZT, who has a strong DAB knowledge. So if you have any kind of questions, just you can ask both of us.
Okay, thank you very much. See you later. Okay, ladies and gentlemen, welcome back to this next seminar. And I'm really happy to have our next speaker, who is Stan Röhrig from Digis AG from Geneva. Stan is, I think everybody knows him. He's Mr. DAB himself. He knows everything about DAB. If you have a question on encoding, multiplexing, distribution, planning, Stan is really an incredible expert on DAB. I think I appreciate his knowledge really a lot. And he will give us a presentation on how he managed his signal distribution on the Digris network in Switzerland, and how they plan and maintain this. So it's very interesting. Welcome, Stan. Thank you very much for being here.
Thank you, Hans. You will make me full red, like my vest. Sorry. Okay, thank you. Hello, everybody. So I just start with a short introduction. So I'm working for a company in Switzerland called Digris, and we are a DAB operator. To explain, just to give you the overall landscape. So we started several years ago, and the goal was to provide a solution for DAB+ for the small radio station, because at that time, most of the discussion were about frequency planification, technical solution for large national network for DAB+. And we had the feeling that if you don't take everybody on board, if you talk about digital migration and you forgot the small radio station or the local one, we were thinking it's not a good idea, and moving to digital will fail if we just forget some part of the market here. So that was the main, let's say, motivation at the beginning. And we did apply for a license in Switzerland for local coverage, and luckily for us, we won it. And then when we had the paper, the serious thing started, because we had really to deploy a network. So we started with MFN coverage, so no SFN and no synchronous network. And Geneva was one of the first cities, then we had Zurich, and then more and more we did grow to cover the various area. And our main customer were local FM radio station. community radio station, but a lot of newcomers coming from the web radio, finally, we can say. Later, so we did continue to grow in Switzerland, and later we had also interest for France, and we decided to also go into this market. We choose some partner also because when you deploy a network, you need to find site, you need to have contact, so you need networking with people to then make things happening. And for example, now in France, we have more than 300 services on air for the local and regional market. And in Switzerland, it's a little bit less because we are a small country. Huh? Don't forget that in Switzerland, we are a bit less than 9 million people. So if you take just Paris and area, it's already quite more than just population of Switzerland. And we also started later in last year, in fact, in UK for the small-scale DAB new license, because UK did phase out the test period for the small scale, and now since a year they are now allocating new licenses. So we are also present here, and in fact, one of the guys who was working at Ofcom to launch this project is now working with us in UK. From the beginning, we started to work with the solution, the software solution, Open Digital Radio. We are also part of the Association Open Digital Radio. In fact, the main developer is also here in this room, Matthias Brendley here. And finally, we did added progressively features in the Open Digital Radio tools to fit our needs and the needs of our customer. And when you start from tools you use in the lab to demonstrate concept, and then when you go to a real operational, let's say, world, it's not the same story, because even if everything works well in a lab, then when you have to provide services with SLA, with real contract, you need to add all the, let's say, monitoring, the robustness, and something that allow you to manage quite complex setup sometimes with a minimum of people. Again, when we started, it was clear for us that the whole infrastructure will rely on IP transport. It was no question to go to, let's say, ETI using E1 connection, because that was a bit too costly for the small radio to build everything on a synchronous infrastructure 10 years ago. And we were also thinking that we should focus purely on IP for our development. So, sorry. Alors, in 2014, that was the year when we had the first services. And as I said, EDI was finally the main streaming protocol we were using for DAB transport. So it's valid, it can be valid from encoder to multiplexer and multiplexer to transmitters. But we didn't have immediately the software ready for that. So we had also to use different tools. And one of the issue, how can you have a reliable transport over IP, especially when it's not always your network, you use third-party network. Satellite was not a possibility for us because it was too expensive for our customer. And also you have you cannot demonstrate a model that will work to use satellite for a local coverage. That's really too expensive and not suitable for that. We are not against satellite, and we use satellite today for some of our customers, but only for reception, to receive some sources. Our customer who starts to go on DAB Most of them, they were happy to contribute their content via standard XDSL, FTTH connectivity, so a really pure consumer-grade connectivity. And that's where we decided at the moment to use some library. So some of you have already heard about ZeroMQ, which is a network library. And you will hear about ZeroMQ on a further presentation. So we started with that because it was there and Matthias was keen to implement this. And the goal of that step was to have forward error correction, to have interleaving, to have even encryption if you want to, let's say, why not protect your inputs of the multiplexer in addition to other protection you have on the network side. And so we started with that. And we were happy. But very quickly, we saw that some manufacturers, they started to look also at ZeroMQ. And then it was a bit of a problem for us because we say, hey, we use that for, that was finally an internal needs. But if you want to implement something, a protocol to have a reliable transport, maybe we should stick to some more standard or recommendation that already exist. At that time, SRT for a secure, reliable transport was not on the table. But that was finally a way to do that. And later we decided then to say we have to do not anymore just UDP with forward error correction, etc., but move to TCP, because if we see that manufacturers on the market, they are maybe ready to implement a library that we were using on Linux. Maybe if we use finally a real EDI with TCP session, pure TCP session, then okay, they will implement it, because the problem is it was not available on transmitter inputs. Then we did continue to grow because more customer, more coverage, more requests. So in parallel, you have to continue to develop. You have more customers, so you have also to develop internal tools for back office, support, monitoring. Monitoring is really important, and monitoring of everything, not just the monitoring of the transmitter or if your site is online, but the monitoring from the source. And it's where here we had to continue to make effort on further development, and SFN came. We had now to improve our coverage because we had done, let's say, 80% of the mandatory coverage for the local business, but now we had to improve that. And also, Ofcom, the regulator in Switzerland, decided in the frame of DigiMig, which is in fact all this process and project to move from analog to digital for the radio, they decided also to increase some of the coverage we had from the beginning. Because if you do an FM switch off, which is still today the roadmap in Switzerland, we had at least to ensure that for some FM radio, local FM station, we had at least the same coverage or more. And this SFN was important. And here it was a big effort because we had to start to really care about syncing transmitter, to have some features also in Open Digital Radio, to have the timestamp implemented, etc. And we had also to put in place some gateway. And at that time, we were using, and we still use our own gateway. So ZeroMQ was used in our gateway before the transmitter, and now we move to EDI. We call it EDI to EDI, where you implement also additional feature like several source to the gateway, or even why not having parallel stream, and when you lose one, you lose some packet on one, you can reconstruct with the other one. So the kind of things you may know if you are using today, for example, tie-line codec, audio codec, they do also these kind of things. So idea was to implement that also at the EDI stream. As I said, we use internet, we use IP. Some of our customers, they have their own encoder on their premises. Some other customers, they have a web stream, so we encode for them. So we use hardware or software solution to encode. And to get more control about internet route, we had then to get our own AS, so to have finally to be present inside internet, because that's the only way. If you want to have a control about what's happened between your customer and your infrastructure, it's the only way for the customer who use only internet to feed their content to have a control on the routes between them and you. You can choose with peerings finally how you interconnect with the rest of the world, and you will choose the people that will provide the shortest route with your market, with your customer. So it's the case for UK, the case for Switzerland, and for France. And with that, you really start to improve the reliability. But you have to care about that. It's not free. It's a job. I mean, you need to follow. I mean, you do network management every day when you start to work at this level. So BGP, that's the protocol mainly used, but not only to manage or to announce or not a route. I mean, the worst case is when one operator has a problem, but the route's still there, but they cannot really carry the content, bandwidth-wise or other reason. It's not good because the routes stay valid and the customer will try to still use this route. So that's then your decision to say, I kill this access and I will force this route via another operator. So again, that's why it's important to have your own AS in this case. And internally, we use mainly, but not only, OSPF, which is Open Shortest Path First protocol, to do the routing between our sites, our infrastructure, etc. So meaning that with IP and partly consumer technology and real internet core network product, you really achieve to get something very resilient. So yeah, we did move from 0MQ to EDI. Alors, we also had to add another concept, which is the versioning and the deployment tool. Because when you start to grow and you have more than, let's say, 80 sites to manage, a lot of customer, a lot of service, you have to really control from the small switch, the small router, up to the main transmitter or the main core network. 5 minutes, okay. Core network router, you have to manage the version and everything, and you should not accept any discrepancies in your network, because it's when problems start. We did integrate also tools for advertising. We had also Pad Tools, which is a tool to manage the slideshow and to add some revenue stream to our customer. Especially the small one, because the large one, they know how to make business. Small one, it's a different story. So we added some facilities for them to have a local advertisement. So insertion of display, Adcast, the product is called, and we can target locally or on several areas and insert specific metadata with this kind of tools. And we can also interact with radio DNS to also ensure that when a radio declare their logo and everything that we use, for example, for SPI on the EPG services, we can also declare this same information to radio DNS. The problem we see, especially for the car industry, is that some manufacturers today still use some private or different databases that are not really official, and this creates problems sometimes for the visibility of the radio station in a car. So that's a very general overview of finally what we have today. So we virtualize everything, and when I say virtualize, it's not a cloud solution from EC Cloud or Azure or I don't know. I mean, that's important to rely on your own infrastructure for broadcast real-time content, etc. So finally, we use the same technology as the big internet player, but we put it in place. And as we still like Linux, open source software, etc., we use Proxmox, for example, for the virtualization cluster, and we run everything, the monitoring, the metadata, the encoders. And what we do finally is we have at least 2 different geographical clusters to make sure that in case of problem, we can continue to operate. We have even a third one, a small one, at our office place that could also run the business in case, but with less security because less interconnection, etc. And for the site, more we grow and more we interconnect the site to have a mesh and loop topology to really secure in case of failure. Because with a large network over several countries, every day you have a problem on the network. It happens all the time, but it's not because you have a problem on your network that you have a service offer. That's what is important here. And we really transport between all this link EDI without any problem with the additional protection layer. And we have also added MPLS tunnel with some with other operators, because when you finally grow and you have sometimes common customer with other operators, so why re-encoding again the same audio? You could share directly the encoder source. The same, for example, you can send your stream output from the multiplexer, because in one area you have maybe 2 sites that are good, and the other operator, they have a third site which is good for another area. So finally, to have the best coverage, you can share with other operator sites. So that's also important to keep in mind, to interconnect with other people in a secure way. And otherwise, probe. So the probe is also part of the monitoring system, especially for SFN. We implement a lot of mechanism to prepare the stream before the transmitter, because what we see is that you never have at 100% security. You cannot ensure at 100% that your transmitter will always play properly your source, your EDI source. Not just a question of timing, but sometimes they may modulate something which is not really your data. You don't know why. It's not happening often, but it can happen. So if you want to sleep well and have some automation to make sure you restart the stream properly for the transmitter at the input with the gateway, typically that's the kind of thing we implement and we monitor all the time, real time, to make sure the network is, if there is a problem, immediately it's working again. So the worst case will be a glitch if a transmitter become crazy, a glitch of let's say 2-3 seconds, and then it's back. So you don't have to wait that some listener call to say, hey, since 3 weeks we don't have a coverage in this small remote valley. That's not good. So that's basically what finally we do. And the last thing, I shortened because the time is already there. The last thing is we still work on new development. The audio insertion with in-band signaling to allow the radio to trigger local advertising that we insert before the MUX, but in a proper way. Because they trigger when so that's why we call in-band, they trigger when they want to have the advertising. But we insert everything, and then the agency for ads, they can directly use the web portal to manage their campaign. So that's called AdSpot. A small transmitter gap filler. We have a project working also on that with Matthias. We hope at the end of the year to have something ready. Today we have 2 prototypes. The goal here is to have a small unit, easy to deploy with Ethernet inputs that don't need a gateway before, or so sorry, it's not good for 2WCOM to sell gateway, but it's only a small one. It's not for, we will not become a manufacturer for a transmitter manufacturer, but it's to have everything in the transmitter with the right mechanism and enough resource and power on it to remove any pre-processing. That's it. And then, yes, internet streaming, but that's mainly because our customers ask more and more service from us, because we see that on a lot of radio stations, they have less and less, finally, people available to do to care about technology. And we see that, let's say, mainly in half of our customer base, they ask more and more that we do I mean, some of them, they even ask us now if we could run the automation for them and to host everything. So that's it. Thank you.
Thank you very much, Stan. Hello, yes. Thank you very much, Stan. This was an excellent presentation. Very interesting. I have seen the questions coming up on the paper. Please send in questions for Stan also. We'll have a lot of questions for you. I need the clicker. So now I introduce Emanuele Mancuso, who is a network assistant at Dabitalia, so the company I also work for. And Emanuele will go a little bit deeper into the SRT technology for ADI distribution, which Stan mentioned before. And yeah, the stage is yours.
Okay, thank you everybody. Good morning, my name is Emanuele Mancuso, and I've been working on Dabitalia since 2020 like a network assistant. I'm focusing on integration and development of IP network for Dabitalia. Today, I will explain you my experience with the distribution of ADI on the network, also with the use of SRT protocol. SRT, ADI. ADI is an encapsulation and distribution protocol for an STI or ATI data stream compliant on a IP network. ADI packet is a 24 millisecond of ATI or STI data stream. ADI is designed to distribute STI or ATI data through a IP network with a limited packet loss. ADI could be distributed over unicast or multicast mode in UDP or TCP protocol. An ADI stream is around 2 megabit. In unicast mode, the ADI stream is a point-to-point distribution. In this slide, we can see the multiplex here can generate and send directly the ADI streaming directly to the DAB transmitter in transmission side through the internet. We can send also this streaming to an other side, not just only one. To do that, we made to generate a new streaming, one of each transmission site we can add. In this example, you can see in the slide, you can see the total amount of the bandwidth is 6 megabytes per second. Another method to distribute the ADI streaming is using a multicast mode. Multicast is a point-to-point distribution, but we don't use multicast directly to the internet, but we need to use a VPN tunnel to do this. We also need to use a protocol-independent multicast, like PMI protocol, because this is responsible to make the routing of the data of the stream through the network. As you can see in this picture, we have a multiplex here, generate any ADI streaming multicast, and send to the VPN tunnel to the transmission site using the internet. Like the unicast distribution, we can send the ADI streaming through the network to a lot of transmission sites. In this slide, we have a generating of, oops. Okay. Okay. We can generate the ADI multicast here and send this streaming to all the site using only 2 megabytes per second. Using the ADI streaming directly to internet, we saw a lot of error, and we decided to use a SRT protocol to encapsulate the ADI for make more stable the distribution. We use SRT, is a secure reliable transport protocol. Is an open source live video low latency distribution protocol. It is designed to operate over a noisy network like internet. SRT provide a connection and control like a TCP streaming, but using UDP transport protocol. It supports a packet recovery using the latency buffer. SRT also support an encryption and AES encryption. UDP to distribute these the data use a bidirectional UDP tunnel. As you can see, from the source to the destination, you can send the ADI streaming, but the destination, SRT destination, send back a control information to the source, like the number of packet it received. One of the problems we see on ADI distribution over the internet is a shortly link failure of the network. SRT react to this fault in two ways. The first is the SRT destination have a latency buffer that take the output up, and the other is SRT have time to re-ask to the sender to resend the packet that are lost. Another problem is the packets are distributed, maybe arrive in wrong order. SRT is able to reorder it using the using the buffer. We start to the distribution of SRT using a sample application called SRT Live Transmit, provided from SRT Alliance on the GitHub on official repository. SRT Live Transmit is a tool for encryption and decryption of the data. It is an agnostic data tool. You can use it to encode or decode all of the data you want, but it uses a UDP data. Okay. Okay. To make them to make our example, we use a Raspberry Pi 4 B+ to run this process on it. We have one multiplex site located in Milan that run an encoder process. We also have four different transmission site where we use a distribution of ADI using the SRT, and these sites are Rome, Bolzano, Palermo, and Lake Garda. The basic example you can see in the picture is one multiplex that generate an ADI multicast stream. the SRT encoder bring the ADI multicast and encode it to the SRT on SRT protocol. It sends the SRT streaming to the transmission side where we find a SRT decoder here that take the SRT streaming and decode it to the ADI in ADI multicast like the previous ADI. To start this example, we run the top and bottom command to run this example on the Raspberry Pi 4. The SRT live transmit output some statistic data on the terminal, like the number of packet. The number of packet he sent or received. In this case, is a decoder. Other data are the RTT link, time link, and another data. Okay. To see how many results the SRT live transmit application absorb, you can use a top command on the Linux. As you can see, the main SRT live transmit on this decoder, SRT decoder, use the 12% of CPU and 0.2% of memory. In this version of a Raspberry has a 4 GB of RAM. Conclusion. In conclusion, SRT increase the reliability and transmission of the ADI streaming. We can start of using SRT with a few €100. We can purchase only the SRT encode and decode unit to make an SRT encode and decode, and a good quality network. It is good to have a connectivity with a guaranteed bandwidth to increase the stability of the distribution. Before we use a SRT protocol, we send the ADI using only the multicast mode, and we can see a lot of error to the transmission side. But when we start to use the SRT, the problem are finished. We have noticed one error on a week. It is a good solution for us. Okay. And thank you everybody for the time. Thank you.
So, thank you very much, Emanuele. Very good presentation, very interesting. I'm sure you will get a lot of questions. I see there are already some available. And at this point, I am very happy to introduce Laurie Hallett from Norwich. And he is the manager of it's very complicated for me, sorry, for Future Digital Norfolk local DAB MOOCs. Laurie has, I think, incredible experience. I was shocked yesterday to hear he has been involved in everything from FM, from the early FM to radio in Italy to he's been working in Ofcom, and he's now a professor at university. So he's really a lot of talents, I think.
They won't let me be a professor, but apart from that, yeah.
Okay,
and it's
sorry.
what happens when you get old, basically. So.
Okay, here's a clicker, and
thank you, Hans. Good morning, and thanks first of all to WorldDAB for inviting me to address this gathering. Let's tell you a little bit about, actually, before I start, if you notice, if you look at the agenda, you will see that everyone else is a speaker, and I am a speaker. That worries me. Someone knows me too well. Just somebody do that if I start talking too much. So, Future Digital Norfolk Limited. We're a not-for-profit company. We were founded in 2014, actually. We started broadcasting in 2015 as part of the 6-month experiment run by the British Ofcom. I did warn them at the time that 6 months wasn't long enough. Indeed, it wasn't, and we got that license running through until the end of last year. So much for 6 months. We got the long-term DAB broadcasting license for Norwich towards the end of last year. So we work closely with the operators in Cambridge, and we also run a shared ownership of a smaller multiplex in Kings Lynn, which is a much smaller town in the north of Norfolk. Essentially, it's the bit that is nearest to the Netherlands. We carry just under 20 services, mostly in DAB+ at 48 kilobits per second. It's very interesting, actually, when you look at the way small-scale DAB is implemented around the world, the different bit rates that are used. It seems that 48 kilobits per second for stereo services is kind of become the norm for the UK. We're often asked to do it at lower bit rates, and I try to say no because it's not so good in terms of quality. We also provide support to a number of other prospective DAB broadcast operators. So we began operating with the trial service, and that trial service was a single transmitter, and that was run on DAB Block 9A. It was one of those 10 trial licenses, and it was, thanks to Matthias and others, it was using the open source software. Provided a set of kit, as you can see there, which was actually provided by Ofcom free of charge for the trial operators. So that was our coverage broadly in terms of the trial license. With our, sorry, apologies for the scales being a bit different, but we now operate multiple, at the moment 2 transmitters, a third and a fourth due to come on, and you will notice that they're very close together. The reason for that is that we're seeking to cover the main population centre, which is essentially the city of Norwich. We want to serve that robustly. It's a medieval city. It has lots of closely located streets, tall buildings, stone, etc., and more modern concrete buildings, so you need a very high field strength. So having multiple transmitters around the city means that we have that robust coverage. It also means that should one transmitter fail, we don't have to get out of bed at 3 o'clock in the morning to fix it, because broadly 90+% of people won't even notice that something has gone wrong. I won't go through, spend too much time with this, but this is essentially the basic block system for a single transmitter, nicked from Rashid at Ofcom. Thanks, Rash. And this is the way we run at the moment. If you start at the bottom of the page and work your way up, we have individual stations streaming, and originally they were 0MQ streams. We now use EDI streams, and they consist of audio, text, and still pictures. There is an optional intermediate ingest server. One of the things that we did wrong at the outset was we gave out public IP addresses, so the individual stations send direct to the transmitter. Big mistake, shouldn't have done it. You live and learn, but most things go through an ingest server in the cloud, and that means that we can take their stream, their official stream, the one they want us to take, but we can also automatically fall over to a web stream to back up in case of stream failure. So those are then ingested into the multiplex, and that PC-based multiplex creates the EDI stream, which is fed to the local transmitter and to the remote transmitters. So we use either pushed services via a Raspberry Pi or via a NUC, or we can pull them, as I say. The primary and secondary backup streams are usually provided, and with all the bells and whistles, the pictures and the text data, and we often find that they fail, which is again why we can inject them closer to the multiplex should we need to. So, for example, automation systems which give the now playing information, we have a number of stations which for a lot of the day will be using that automated system, but then they'll go to specialist programs where they may be using vinyl or CDs and that data isn't available, so that our system automatically defaults to generic messaging to go with the receivers that take DLS. We're not yet using the SPI implementation, although we're thinking about it. As I say, they send to a predefined IP address or addresses, and they terminate at our original test DAB site. So our multiplex is unusual, our network is unusual in that it is an ODR transmitter at our original site, and it's a Gatesair transmitter at the second site. And for various timing reasons, we don't create the MUX and feed it into the ODR first. We send over a microwave link to our second transmitter, create the MUX there, feed that in locally to the Gatesair transmitter, then back over the microwave link into the second transmitter. Someone here much wiser than me will know why this was the case, but the timing simply would not play ball if we did it the first way around. It's worth saying that if somebody said to me, what is the most difficult thing you have on small-scale DAB multiplexes, aside from a lack of resources, it would be the connectivity issues, the failure of connections. So at our first site, we have a standard XDSL internet connection, which is a domestic internet connection, which happened to be available when we were doing the 6-month trial. And one of the problems is if you're doing a 6-month trial, you're not going to invest in it because it's only for 6 months. That 6 months trial, as I say, went on for a long while. We're still using that XDSL connection, and it's pretty reliable, but we back it up with a wireless Ethernet first mile. So if there is an issue with the BT provided service, we have a local service which backs it up. We're changing around the system, so those IP addresses, which we should never have given out, 2 problems with them. One, it's public, shouldn't be public. Second, what do you do when you need to change it? If you've got someone pushing a stream to us, they have to make a change at their end to change the IP address. So we're going over to fully qualified domain names so that we can then route to the IP addresses that we need to route to without causing problems for customers. As Stan said, one of the issues is that increasingly stations don't have engineering capacity. That doesn't exist. And what you find is that when you're looking at running a multiplex or even looking at running a station, you can do things with money or you can do things with expertise. And what you find with a lot of stations is that they might have the money, but they definitely don't have the expertise. So there are things that we can do on our multiplex because wiser people than me are available to run the system and understand it right down at the detailed level. A lot of other multiplexes don't have that, hence Digris and other companies coming into the market to provide that service because the level of expertise is simply not available in the market. So I'm not going to go through this in too much detail because it will take too long, but effectively we sent our signals to an Intel NUC, creating both the DAB multiplex and the modulation waveform for the SDR. The current setup, as I say, it's a hybrid. The original ODR equipment is retuned to our new block of 9C. That's because Belgium's rollout, and we're right on the East Coast, Belgium's rollout of DAB meant that the interference levels were just coming up too high on our original channel, so we had to change to another channel. So the 2 sites are connected by a point-to-point microwave link. It's currently configured to transport as an internet connection. Again, big mistake, shouldn't have done that. I'll come back to why later on. We feed those EDI feeds to arrive at Markham Tower. They feed over to our second site at County Hall, create the composite EDI stream, send it to the Gatesair, send it back. We have another site, it's cleared for use in the northeast of Norwich, and we're looking at a 4th site. And again, as I say, that's for robustness of coverage and reliability issues. So if one site drops, we don't have apparent problems for listeners. The biggest problem we've had is contractual, actually negotiating the leases, negotiating the access, and then getting in the data connections that are required. So it's a process. It's something that's ongoing. As we look at the coverage, as we understand the coverage better, then we move to a situation where we can then look at where we need solutions. And I'm very interested. I have known about this before, Stan, but I think these drop-in low-power fillers, the UK Ofcom seems to be of the opinion that within the broad coverage area that's defined, if you want to drop in a small filler just to solve a problem in a very localized area, that shouldn't be a problem. However, having worked for Ofcom, let's see what happens in practice. So I'll go through this very quickly, but that is our interface for the gates air that we use at County Hall. So what would we do differently? It's that old joke about, you know, how do I get to Dublin? And the Irishman, there's always an Irish joke in the UK, says, well, I wouldn't start from here. And we wouldn't start from here just because it's grown piecemeal over time as things have developed. So, you know, it would be nice to be able to start with a clean sheet of paper, but that's not the way the real world works. We certainly shouldn't be using publicly available IP addresses. I wait for the time when we have somebody doing something to that they shouldn't, because I'm surprised, quite frankly, it hasn't happened yet, even if it's just a DNS attack or whatever it might be. We should also be using VPNs and tunneling and encapsulating the data properly to make it more robust. The microwave link between the existing two sites should just be effectively a long virtual Cat5 without the internet connectivity, because the issue is timing. Every now and then you will get a big timing glitch on that microwave link, and the problem is that that then causes distortion of the multiplex. So if we can get that timing completely synced up, that problem should go away. We should have a second standby MUX. In theory, it just hasn't happened yet. And as I say, we think that some of the ingest needs to be modified. It needs to be simpler for the customer, because at the moment the customers we'll send them a Raspberry Pi or we'll send them a NUC, we'll set it up, and then we have to access it remotely. They have firewall issues because we don't have control of their firewall, et cetera, et cetera, et cetera. So those sorts of things we really need to look at. I think that pretty much covers it, but as I say, what we really need to do is remove those public IP addresses. How do we monitor? Stan said the importance of monitoring. We have a number of solutions. We use this little box from Innovonics, and that's publicly available on our website. If anyone wants the passwords for it, I'll give them to you, because it's not connected to the system. You can see what the multiplex does. You can see individual services. You can see the state of the MUX. You can see the RF, et cetera, et cetera, et cetera. But you can't touch the MUX because it's literally a standalone receiver with no connections and no interface to the operational side of the multiplex. We also use quirks, and we use quirks mainly to make sure that the synchronization between the two transmitters remains stable. Touch wood, it does. And we use ProDBR just to look at long-term behavior of the multiplex. In addition, at the cloud server, we actually have monitoring of the individual streams coming in. So we can see what's coming in, we can see when they drop, and we can put in backups should they be required. I think that's it. Thank you very much.
So thank you very much, Laurie. Very interesting presentation. At this point, I would like to ask all the speakers on the stage, because now we have the Q&A session, and I have an incredible list of questions already popping up. If you have questions here in the audience, do you have a microphone? Or yes, please push the button of your microphone in front of you, and maybe say your name just as a question. Okay, I sit on the side. Okay, so any questions from the audience for the beginning? Okay, Glyn?
I wasn't necessarily saying for the beginning, and I'm a freelance. I used to work for a big transmission company and used to use satellite distribution, and was always intrigued by internet distribution. We used to use the internet for some ingest to the multiplexer. There's two questions, but I'll ask the first one first. How many sites do you need to have before satellite becomes cost effective? I think the number's probably about 30, but I think it's probably coming down year by year. So I'd like each of you to say how many sites you think you would need for satellite to become economically viable today, and how many sites you think you would need in 5 years' time for satellite still to be the most cost-effective solution.
I can just say I'll never answer that question because I don't think we'll ever go to satellite within my lifetime, just because the numbers are so small.
But if you're running a different network, Laurie, because you've got a better understanding than most of us, how many sites would you think?
I'll be completely honest with you, I don't know what the current costings of satellites are because we've not had to be involved in it. I mean, it's clear that it would have advantages in terms of reliability. As I said, the main issues we have are reliability issues with the internet connections. So if we could do it cost effectively, we would, but I've not looked at that because at our current scale, it's beyond us.
Yeah, I was talking about satellite in the presentation, and in fact, in our case, it's a bit difficult to use satellite because we operate a lot of sites, but let's say 80% of them, that's local coverage. So if I have to use satellite at Digris, I need to contract, I don't know, maybe 40 times 2 megabits capacity over satellite. So let's say each satellite link will feed between 1 to 4 or 5 transmitters. So that's why it's not suitable for us. I would say that I could use satellite if I have to maybe, I remember some price from Belgacom or other company in Italy, etc. I would say, I think today, if I have to feed about 40 transmitters in Switzerland, maybe I can start to think to choose a satellite option from the price we know here to run our microwave and everything, etc. I compare that. So let's say for one single 2 megabits. Then I don't know about the condition for backup capacity if the satellite do a flipover and how many times they can reestablish, because you know that if the satellite is in backup mode, they won't turn it too fast to keep some, to don't reduce the life of the satellite too fast. So depending which type of capacity class you will also take for your network.
From a manufacturer's point of view, we had this big project, Norgring Telenor, and they, as you know, have existing satellite infrastructure, and it's only adding more content to an already existing satellite infrastructure. So at the end, we think for them it's a good way because it's just they add DAB servers to the existing platform. So, and at the end, the costs were not that high. So but of course, it's another perspective because all our customers still have existing satellite infrastructure. They just add DAB services to them.
Okay, I will answer instead of Emanuele on this because I've been just longer on the distribution part. When we started the rollout in Italy over 10 years ago now, basically EDI was not finalized and not all modulators supported it. So the distribution, if we would have done it terrestrial, had to be via microwave links and G703 links. And that would have been very costly for a national network. Therefore, we went to a satellite solution at that point. Nowadays, where we have IP basically available in most transmitter sites or in all transmitter sites, I think we could put the number around 20, 25 sites. So very similar to what Glyn is proposing. So in order to have comparable costs, you'll need to have at least 20, 25 sites. Okay, so any other questions from the audience? No? Okay, then I will start asking questions because I got a lot of questions online. And I will start with a talk in this case. The first question comes from Nick Pigot from the UK. And he asks, what kind of reliability do you usually expect for distribution of ETI over satellite?
Yes.
And how does this compare with the IP connectivity?
Yes. Norcring Telenor showed us some graphs as we visited them, and they have a really high availability. The availability was much higher than I think 98%. So they are monitoring all their satellite system at certain points and made up availability charts. And for this very remote areas, they don't have a different choice. They have to use satellite. But as Norcring and Telenor told us, they were really surprised how good the stability was. So they have quite a huge analysis done. And the availability was very high for the satellite networks. Of course, they had the big satellite dishes that were heated and stored at all their huts. So they had a good reception quality of all the satellite feeds.
Okay, thank you very much. Next question goes to Stan from Phil Casby. Have you encountered issues with the synchronization of transmitters in the SFN due to the variable distribution of IP over the internet? And this is a question which pops up a number of times, I must say. So I would also have an answer from Emanuele on this from his perspective.
Alors, yes and no. Yes, in the beginning, when we started to play with the system before to go in real operation, because of the nature of the asynchronous network from an IP network, simply. Then the work was exactly to solve that issue. So let's say that since we have put in place the software, the management of buffering, and not just only error correction, several routes, etc. Because even when you switch routes, you have also the timing who is changing. So you were talking before about the variability of the delay on IP radio link, depend which kind of radio link you use. Yes, you can have this. Our idea was really to say, we will not change the nature in IP. It is there, it's like this. So we have to put in place additional mechanism to overcome that issue. So what we do finally is, yes, we give a bit of delay. The price for that, it's latency. You have to have some latency. And the latency, you need it to manage this delay variation, to also add mechanism to do typically the error correction, interleaving, selection of different sources, etc. And in addition to that, you should hide finally to the transmitter what's happening before. The transmitter, he will receive a stream from a local gateway. And finally, the transmitter don't know what's happening before. He receives something that he knows he has to play on at that time, at the shortest, let's say, with the shortest time interval. So that's why we do the job before. So I'm not saying that transmitter is, they don't do the job, but they have implemented the EDI as it was described at the origin. But to really manage problem from an IP network or even internet, that's really some, let's say, different experience and knowledge. So I was lucky enough to my previous job to work on that issue at the EBU. So we knew exactly what was the issue finally. And the other problem is also that when you start to mix transmitter brands, they don't behave in the same way. First, they don't have the same processing time. Some of them need longer time than others. So you should finally put a base where you mix, when you mix equipment brands, you put them all at the same level at the moment. So that's why finally you have to work before the transmitter, because you cannot ask to any manufacturer to finally implement exactly the same thing. They are all finally a bit their own platform, own cooking experience. So you have to overcome that in this way with previous mechanism. And when you do that, it's good. And then you have also to accept that if the network become too unstable, let's say you lose your backup connectivity, you have only one remaining. And we did, for example, test over 5G, 4G, just to play. And you wait the peak time when people are all on in the social network and push video on the network. You have at the moment the situation where you arrive at a limit. You have to decide at the moment if you continue to provide the stream or if you just mute it. To avoid also to put the transmitter with too much up and down, because sometimes it can make them crazy. It's also not very good for the high power amplifier behind the modulator. If you always do cycle on, off, on, off, on, off, you will reduce their life. So I will say we can manage 99% of the issue over IP. The remaining 1% is really when you have no network usable anymore. I mean, if you cannot carry a 2 megabit stream, or let's say 4 megabit stream with forward error correction over the network, then okay, you have to fix the network. I mean, you have always to fix the lower layer first before to try to become too complex on the top.
Okay, Emanuele, do you want to add something?
Yes, the main problem in Italy we have the main distribution is satellite. The main problem that I encountered to synchronize the ADI distribution with the satellite distribution is only to find the correct value of the buffer in the sender on the multiplex and on the transmission side on the transmitter of the buffer, because because we need to find the exactly second of the satellite distribution arrive. Thank you.
Okay, just one more question for you, Emanuele. This comes from Talina Milling, and which says, did you consider to use the RIST instead of SRT protocol? It's a protocol in development coming from the broadcaster side instead from the manufacturers, and it has some features as parallel redundant connections, etc.
Yes, we don't. We use SRT because was delivered from before the RST protocol, and because we I think in the bidirectional UDP transport is more performant for DAB distribution, and because SRT are data agnostic, because it doesn't matter what are the data, what the data are, but use only the data you can pass and send it.
Okay, so the next question goes to Laurie. This is a little bit different from the approach, and this is, what are the operational costs of your system, actually? Because, of course, people want to understand how much this small-scale distribution is costing you.
I think it's very interesting. The UK implementation of small-scale DAB is is very economical. The amount of money running around in small-scale DAB in the UK is probably the lowest. Stations, to give you an idea, go working backwards, stations on our multiplex pay anywhere between about €1,200 a year to about €4,000 a year for their carriage, depending on bit rate and depending on other elements of how the contract is negotiated. So our multiplex runs on about anywhere between about 15 and 25,000 euros a year at the moment. But what we did at the outset was we said, okay, we're going to keep our recurrent costs down as low as possible. So in negotiations with local authorities and with universities, we have incredibly minimal site costs. So fundamentally, our operational costs are interconnectivity and maintenance support. So I would say probably the idea is that if we make a profit, it goes into our local community radio station. So any excess we make, it's a not-for-profit company. Any excess we make goes into the local community radio station, and they get in the region at the moment of about 5,000 euros a year, I would say. So operational costs are between 10 and 15,000 euros a year, I would say. So it's very, very minimal. And that was specifically the objective, because when you're looking at very small markets and when you're trying to encourage new entrants, and a lot of, as Stan said, those new entrants are often webcasters effectively, and they don't have the economics that traditional broadcast radio has. So just trying to keep that to a minimum is the primary objective.
Thank you very much. Tork, from a question from Martin Acklin from SRG SSR. He asks you, in the case of a feed via satellite, two questions actually. How is synchronization ensured in a single frequency network? What technology is used? And what has to be considered for the outdoor hardware, for example, regarding snow and ice? And I also add one more question, sorry, because do you have problems, for example, with sun outages at high latitudes?
It's for the satellite system, it's always that you have to be on the right second. So for the satellite, it's a lot of delay to your IP EDI distribution. And at the end, but this delay is pretty constant. So that's very good. You have a constant delay, so you can calculate. So at the end, at the DAB transmitter, you have a network compensation delay. And this network compensation delay, it's the delay that's buffered at the DAB transmitter extra to play out at the exact time point. And this time point is derived from the timestamp information. So DAB transmitter typically has a 1 PPS or 10 megahertz input that's derived from the GPS system. And based on that timestamp information in the ETI field, it knows when to play out the DAB signal. So if you have a constant delay in satellite distribution, you can calculate how much margin you have for this distribution. And you can, by calculating, you can simply adapt your timestamp in that field that you have enough margin left for your EDI transmission. So a lot of our customers calculate this, see what's the margin for the transmitter delay, and then use the right values to ensure that every DAB playout is in the right second. And for the second question, as we are manufacturer, we do not have much details about sunbeams and something like that. We know that this system is working very good, very efficiently. But yeah, we do not have any kind of extra maintaining data from our customers.
Okay, thank you very much. Concerning the sun outages, we are experiencing this in Italy, which is of course a lower latitude. And twice a year we have, let's say, a 3-day period, generally speaking, where we have this problem and it's very difficult to address because basically you're helpless. So in that case, you need a backup system. It's very complex. Oh, we have one more question. Thank you.
Hi, I'm Oscar Thompson. Similar question to the one that was asked to Dr. Lawrence here regarding the costs in Switzerland with regards to hosting a station and stuff like that. So that's my question.
You mean the cost for your yearly cost to have a program on air on DAB plus services? Well, I will give you price, and they will depend about what coverage you choose. If you take, let's say, a coverage from Romandie Media or Swiss Mediacast for a regional area, so all the French-speaking area, price, okay, depend the bitrate, but let's say you have an average between 95 to maybe 100,000 Swiss francs per year. That's but then if you take a local coverage, you may end up by a price that will vary from 500,000 to about 5,000 to 14,000. And the variation is because it's calculated by the population you cover. There is a mechanism put in place to allow that we can still finance and still build infrastructure in area on the mountain side, etc. I mean, in Switzerland, you have this principle since a while, where if you provide the service, you should, I mean, in the past it was very strong, it's less the case today, but you should provide the same level of service everywhere in the country. But as you imagine, when you build an infrastructure to cover Zurich or Geneva or Basel, you will cover a lot of people because that's the largest city of the country. If you build an infrastructure in Oberwallis, for example, you will have maybe the same cost or even more, because depending the cost of the site, the access, etc. But you will cover far less people. So if you make the same, let's say if you just make the price by the running cost for only one area, then you imagine that you will never have DAB in remote area. That's the reason. So the price is calculated by the number of people you cover. So that's the variation between the 5,000 and 14,000 for a local coverage.
I have a lot of questions coming in on latency, on IP distribution, and this will both go to the three of you who do currently this IP thing. One is, of course, this goes to Emanuele. Do you encounter particular issues, and what are the latencies if you use SRT? For Stan, I have the question, do you see problems with the latencies if you use different transmitter brands? And I think this is also Laurie is nodding, and maybe I would also like his opinion. But let's go with Emanuele first.
Okay, we encountered some problem if I don't set the latency on the process when we run the SRT encoding and SRT decoding, because it adapts on the RTT parameter of the network, and but it is by default at 120 milliseconds. In the previous example, I set it to 20 to 200 milliseconds of latency to have a free of possibility to synchronize all the streaming on the various transmission site. And talk.
Thank you. So, yes, about the latency and the various transmitter, I give a real example. If I check the average delay I have on a network in Switzerland over the internet or any IP connectivity we use, we are always never more than 20 milliseconds for the transport. Then when you have problem on the network, you can see timing going up to 200 milliseconds. If you have higher than this, that's usually serious problem. But let's say so what we do, we take 1 second more. So we say, okay, it's crazy to take 1 second more because you don't need that 1 second. But we do it because, okay, it's a round number, it's easy. And let's say that in total, when we feed the transmitter, we will ask the transmitter to play what we give to the transmitter in the following second when we give the content. So we have the timestamp from the multiplexer. You can play, you can offset the timestamp, okay, let's say. You don't need to use the real timestamp when it has been created in the MUX. So let's say you can do some TIST offset, the TEST offset, and you can also win time by doing that for what you have to do after. Like this, the transmitter, when they get the packet, they say, oh, but I have time. But then if you give too much time, you are not sure you play in the right second. And every brand behave in a different way. That's what we know. So what we do is we don't let the transmitter deciding, we decide for him before. And if we cannot give the packet on time to the transmitter to play at the shortest second, we just mute the stream. So we don't use the mute mechanism of the transmitter, we do it ourselves before. And with that, you solve, let's say, your problem. And you also don't put too much pressure on the manufacturer to implement different behavior for their input buffer also by doing that. So that's finally a way when you use a pure asynchronous network to make something working. That also relax the clock, let's say the clock requirement on the previous equipment you are using. I mean, finally, just the transmitter needs to have a very accurate clock before you don't need if you have enough time to work with your data. So let's say that the important in the game here is don't have long-term shift on your clock. If you have short-term shift, it's not a problem.
Okay, at the risk of saying something where people far cleverer than I will look at me very sternly and say, no, that's not quite right, Laurie. I would say the issue here for us is that delay itself is not a problem. Variable delay is the problem. You can always compensate for something that is fixed. And I would also say that a lot of this stems in our case from the fact that the early DAB standards use UDP transport. And therefore, very useful things like EDI to EDI, allowing us to take an EDI stream, feed it over with the TIST information from the TCP connection, and then recreate the UDP version and feed it back into the transmitter. Like you, Stan, we end up with the magic 1 second of extra time because that seems to work. But every now and then, and this is, I think, to do with local conditions, one of our transmitter sites has a very large mobile telephone operator on the next door tower block. And something they are doing is not right, because on a Monday morning at about 10 o'clock, they seem to run some sort of test and it screws us. And we still haven't been, they've admitted they do something. They can't tell us what it is. They can't seem to explain that to us. But 10 o'clock on a Monday morning, almost every Monday morning, the timing goes way out. And we're pretty sure we know who the person is, but we can't get any sense out of it. And that's because suddenly the timing changes dramatically. As I say, it's down to that variability. That's the issue.
Sorry, okay, thank you. Thank you very much. One more question from Thomas Arapek from Czech Republic, the telecom company. This is open. Who wants to answer? Has anybody used or tested an EDI unicast over a 4G or 5G network?
Yes, we did. If you do pure EDI, it's not working. But if you had SRT or any mechanism, as we explained before, what we use in Digris with the EDI to EDI functionality we developed, or all the mechanism we told before about this timing management and error correction, etc., interleaving, yes, it will work. And to be honest, we had a few weeks ago, 2 operators in one area we were building new sites that had a major issue with their connectivity. One of these 2 operators is a very small one. So let's say they have only 2 interconnection with internet, 2 peering. So one of their customers become under attack, a really strong DDoS attack. They were not able to manage that, and they could not rely on, let's say, a bigger operator that have solution to mitigate this kind of attack. So they could not rely, because usually what you do, if you have partnership, you can have possibility by somebody who have already a harbor or other type of solution to manage this kind of problem. And we said, okay, what we need to know from you is how many times you need to solve the problem. It is days or weeks. And in the beginning, they had no answer. And then finally they say, okay, they need finally about a bit more than a week to solve everything. And we said, what do we do? Do we try to work day and night to help them and to also understand what's happening, or to increase the protection mechanism? And finally, we just put on, because on each side there is a router, we have this OSPF stuff. And again, it was new infrastructure, so we didn't have yet the complete loop ready. I was not able to speed up the process to close the network. So we connect on the router a 4G, 5G modem. And we did run 3 days with EDI over 4G without any problem with the protection mechanism. I don't say you should use that to feed 24/7 a site, because we did measure the same thing over UK on other 4G connectivity, and here I can tell you that on the morning and the evening, the bandwidth is not there. So even a 2 megabit is not reliable on a 24/7 usage over 4G, depending the country. Here we were lucky because the signal was good and it was not overcrowded. So I would say, if you want to play with that to do temporary setup, or you have no solution for a few hours because it's better to use it than having no service. Yes, for sure. But honestly, I will not sleep well if I know my network is running on that, because I know that, you have something very important implemented on every cell phone's data link, fair access user policies. So it means that even with an unlimited data account, they don't always tell you that, but what they do is when you reach a certain volume over the months, as you have an unlimited account, they will not switch off your connectivity, but they will limit the bandwidth you can use with the connectivity. So you have to know what you do. You have to be smart enough to know if you have enough data over the months, even often over unmetered connectivity, because they will limit it. They will limit it because they cannot guarantee full bandwidth to everybody all the time. Otherwise the network will cost too much, and you will pay far more your monthly fee for your 4G SIM card. So that's what we have seen.
Okay, Laurie wants to add something?
Really quickly. We are actually doing this on another multiplex at the moment, because BT OpenReach We ordered a link from them to a rural site in last September. They still have failed to deliver it. So as a stopgap measure, when that transmitter came on last September, we put a 4G link in. It is still running because we're still waiting for that link. And it's down to the location. We tried it somewhere else and it fell over in a matter of minutes because there was just too much traffic. But this one happens to be in a very rural area, and touch wood, it's still reliable. We're just waiting for BT Openreach to do what they said they would do 6 months ago.
Okay, do we have time for one more question? This still goes to Stan, sorry. Stan, you're... and this comes from Werner Mazik, who asks you about Adcast. He says, I would like to know how Adcast works, because getting the timing right with the slideshow is pretty hard.
Yes. So very quickly, we have some rules. I mean, we never change, and that's also a guideline from World DAB. We never update a slide faster than 20 seconds. You remember that was one of the recommendations. So we know how many time we need to send a slide, because we know the bandwidth allocated to send the SLS service. So it means you can send in advance some slide. And for advertising, usually you know when you have to send it. So that's one way to solve this issue. The other thing is we send the slides more than one time. So if there is a window for a spot for a slide, the minimum display is 1 minute. Like this, we can send the slide 3 times. So it means that if somebody is at limit of the coverage, there is some errors, you have additional correction on the audio. But then the slide, if you have a corrupted file, maybe will not show up. So we at least send it 3 times. So that's why it's 1 minute. And like this, we are sure that the people will have at least the ads properly displayed on the receiver. So it's how we finally manage. So the simple answer is we keep it simple. We don't make too much dynamic things. It's like when we send timing or we put a clock on the display. The clock, in fact, on the generation tool who generate the pictures is in fact working in advance also. And it's how we mimic the fact it is real time.
Okay, basically you have 1 slide per advertising cluster in this context.
It depends. If, for example, today what they have done in Switzerland is they have decided to have 4 blocks over the hour for the advertising. And let's say a block is 3 minutes.
Okay. Thank you very much. So this draws this seminar to an end. First of all, thank you to the speakers for being here, for coming here. Thank you to the audience who is here in presence. Thank you very much for coming. Thank you to the online audience for sticking with us until 12:10. We are running a little bit late, but I think the questions were really important and interesting. The presentations which have been shown today will be available on the World Upset website very soon. So if you want to download them and have a look at them, you're welcome to do so. I also want to thank Rebecca for organizing the seminar. She's done a great work. Thank you very much, Rebecca. And also, of course, also the EBU for hosting the meeting and giving us the availability of this great room. So thank you, everybody, and let's see, hope to see you at the next seminar. Thank you very much.